Students, this is the extra credit video 6.6. Don't forget the date, time, location, and getting this video done will prepare you for the next lesson. As a quick review, we're going to trace the rectangle ABCD. So just trace it with me. A, B, C, D. Just trace it. You're going to trace the diagonals AC and BD. You're going to trace AE, BE, CE, and DE. Now, before we go on, just ask yourself, what is true? If it's a rectangle, and by tracing, your brain should have registered the fact that, well, I got right angles here. We also have parallel sides and congruent sides because it's a parallelogram. These are all the things that should be registering in your brain as you are tracing. And what else? By tracing AE and BE and all of those, you should have felt that all these pieces are equal, which means two equal sides, two equal angles, which means these angles here are equal, and these angles here, two equal sides, two equal angles all the way around. Keep that in mind, two equal sides, two equal angles. We get all of this information just from the word rectangle. We are told that A to E is 3x minus 5, and B to D is 38, and the measure of angle EDC, EDC is 49. Knowing that, it wants you to find A to C, the length, and the measure of angle AED. To enhance your own learning, my recommendation is you pause the video and do your own work right now. Pause the video. Okay, students, get out your red pens. Let's see how you did. You should have noticed that it takes two of these to make one of those. So 2 of 3x minus 5 equals 38. That's 2 reds equals 1 blue. And we have 6x minus 10 equals 38, plus 10 both sides, of course, 6x, 48 divided by 6x. 48 divided by 6 is 8. Don't get all happy when you solve for the variable because you have to do something with it. So we're going to go, this whole thing is 38, and right now, 3 times 8 is 24. Hang on. So that's going to be 24 minus 5, which is 19. And of course, 19 plus 19 does equal 38. So A to C is going to be 38 as well. And we want measure angle AED. That's this angle right here, AED, right there. And 49, take away from 90. It's going to be a 41. And if that's 41, this is 41. We add that, that's 82. Take away from 180. And you are going to get 1098. This is 18. And so that's going to be 90. 8, right there. All right, that's our review. Also a review is our rigid motions. This is from the previous class. Translation means to slide. So when you slide a shape, you go this way. A reflection means to flip it over. So imagine a mirror, flipping it over. And rotation means you turn on some sort of pivot point. So I could turn this like so. Those are all rigid, meaning the same shape remains and it just moves around. Dilation is called non-rigid. It actually changes the shape. Dilation means to change in size. And same shape, different size. That should ring a bell. These shapes are going to be similar. So our four motions on a plane are translation, reflection, rotation, and then dilation, which means to change in size. Today, we're only going to focus on shapes that change in size. And of all the motions on a coordinate plane, this personally is what I believe is the easiest. To change in size, just multiply. To change in size, just multiply. We call what we multiply the K factor. It's also known as the scale factor. To change in size, just multiply. So if you want to dilate an XY point by a scale factor of K, all you do is multiply X times K, Y times K. To change in size, just multiply. And think if your K factor, so you start like with an original shape, we'll make a circle. If your K factor is a fraction or less than 1, that means that whatever you take that, it's going to shrink. If your K factor is bigger than 1, it's going to enlarge. So when your K factor is bigger than 1, you're going to enlarge. When your K factor is less than 1, you're going to make it smaller. So K factor larger than 1, you're going to enlarge the shape. And if the K factor is less than 1, you're going to shrink it. And that's just helpful to keep in mind when you do your math so that you can double check it. Ready? So if you want to dilate an XY by a scale factor K, all you do is you multiply. To change in size, just multiply. All right, we're going to do just a couple examples and we're done here. We're going to take this image on the right, ABC, and we're going to dilate from the origin, which means our origin is going to be our center point of dilation, with a scale factor of 5/3. Now, 5/3 is our K here. So first we need to get our points. And you've got to do this very carefully here. Our A is at 9, 9. Notice how I'm using the chart to be very accurate here. Our B, we walk it down, is at 6, 9. And our C is at 9, 6. So I'm going to take those 3 points. Let's write them down. So to change in size, just multiply. We are going to dilate by a factor of 5/3. Now, right off the bat, 5/3 is larger than 1 because 3 goes into 5 one time with 2 left over. So that scale factor is actually 1 and 2/3. So it's larger than 1, so we know we're going to enlarge this. So to multiply, I'm just going to split these apart so it's easy to multiply. Split them apart, and we're going to multiply everything by a scale factor of 5/3. No, you're not going to use a calculator. I got a really, really easy way to do this. It's called arrow in, arrow out. And pause just for a second so you can catch up. Ready? Arrow in, arrow out. It goes like this. 3, arrow in, arrow in. 3 goes into 9 3 times. So a little arrow out, put a little baby 3 there. And then you do 3 times 5. And that is going to be 15. Arrow in, 3 goes into 9 3 times. 3 times 5 is 15. Arrow in, 3 goes into 6 twice. Arrow out, put a little 2 there. 2 times 5. That makes this 10, comma. Arrow in, 3 goes into 9 3 times. Little 3 there. 3 times 5 is 15. And arrow in, 3 goes into 9 3 times. 3 times 5 is 15. Last one, 3 goes into 6 twice. 2 times 5 is 10. There's our new coordinates. So we are going to plot our new coordinates here, and A prime is at 15 and 15. So there's 14, there's 15 right there. And I'm going to have to get closer here. 15 and 15. Right there. Nope, I think I'm off one. Yep, I'm off one right there. Okay, so that is A prime. 15 and 15. And B is going to be at 10 and 15. So there's 10, follow it up. 15. So B prime. And then C is at 15 and 10. That's C prime. Now your end product, it should look exactly the same shape, just a different size. And in this case, we know our size should be larger. Same shape, different size. Same shape, different size. So we had here, oh, I graphed it there. Would have been easier to graph to the right. And let's just do that, 15, 15. You're right. So 15, 15, A prime, and then it was 10 and 15, B prime, and then 15 and 10 for C prime. Once again, if you've done this correctly, it's going to be larger, but the same shape, different size, which means these shapes are similar. If we were to close these up into triangles, you could do similarity stuff with, if you remember correctly, similarity stuff means you can make proportions. Keep that in mind. Anything that is similar, anything that's dilated is also proportional because of scale. Ready? Your job is to do this one completely on your own. And then restart the video and we'll check. Pause the video. Okay, welcome back. Let's see how you did. So here we have P is at -6, -2, and Q is at 2, 4, and R is at 8, -4. And we are dilating by 1/2, which means if I just multiply everything by 1/2 here, 1/2, 1/2, you can see multiplying by 1/2 is the same as dividing by 2. All right, so little baby 1/2, and you should -6. Half of -6 is -3. Half of -2 is -1. Half of 2 is 1. Half of 4 is 2. Half of 8 is 4. Half of -4 is -2. So let's plot that. Notice your scale factor is less than 1, so our resulting image should be shrunk. So -3, -1 is P prime. 1, +2, that's Q prime. And R is 1, 2, 3, 4, -2 is R prime. Same shape, different size. That's exactly what we expect. All right, this page you will do completely on your own. There will not be an answer key for this page. I will be checking this page and I want to see the work. I don't want you just doing the math in your head. I want to see the arrow in, arrow out action like this. For each coordinate, I want to see the arrow in, arrow out translation as you do this. So show that work down here. Regraph your both the original point, the original triangle, and then your dilated triangle after dilating by a scale factor of 3/5.